This
Okay.
conference will now be recorded.
If not, let's get started. Mon, you can go ahead.
No, since I'm trying to finish up, I'll let Jeff go first. I can finish up in the last 15 minutes.
Okay, thank you. Jeff, you want to go for the redfish areas?
Oh yeah, you want me to do that first?
Yeah, why don't you go first? Yeah.
Okay, let's see. Can I have to make me a presenter?
Yes, let me. Okay, I'm over you.
Great. All right. Okay,
Yes,
good.
we can see it. Yeah.
That works. Okay, great. Yeah, and I'll go through this kind of quick because
You can take your time, Jeff. I think we have only 2 topics today.
all right. Well, I don't want to bore you to death on a
Yeah,
Monday.
no, I understand. Yeah, but yeah.
So, all right. So for anyone who's not familiar with Redfish or just the management infrastructure in general, so Redfish is an industry standard. It's owned by the DMTF organization, which is a standards body that has been around for 30 something years now. Focuses mostly on systems management topics, and so that this kind of makes sense. So Redfish is a RESTful style network interface, specifically for systems management. If for folks that are programmers, it is a JSON payloads over HTTP, and the bulk of the work and of the specification is to define those data payloads. So it's the schema, the data model, however you want to word that. But that's where the bulk of the stuff is. So the standard is it's an open standard in the sense that it's freely available. You can download it. There's no licensing to. I mean, there's license, but it's very permissive. But it's free to implement and to use and extend. So OEMs can add their own data, and there's a suite of open source tools and conformance tests and so forth. So an entire ecosystem around this. It's been around since 2015, and it's very broadly adopted among the server vendors. So you can fully expect that if you have a server purchased in the last 3 or 5 years, you should be able to just start talking to it via Redfish and get some data out of it. Because of that, that's the Redfish has become the primary interface that we try to specify or to use for any kinds of new applications and applicability to other devices, in OCP and the various work groups. So since I'm also the co-chair of the hardware management group here at OCP, that's kind of one of my other jobs is to try to get folks to actually use this stuff. So we want to specify some minimum requirements there, and to try to get all the products to have a common language to speak to. So Redfish started in the server management realm, but because there's so much of the setup is just common to really any device and to anything that's a managed device. So the authentication and the security, getting user accounts set up, setting up eventing, firmware updates, system identification, part number, serial number. There's so much stuff that's not specific to a server that really applies to any kind of managed device. And so given that, Redfish expanded over the years to include other classes of devices. So the storage adapters, the controllers, the large freestanding or fabric attached storage. And the areas that I've been more involved with are the push into the data center infrastructure, so the power and the cooling infrastructure. And so we have a lot of ties in with the recent elevation of liquid cooling to an OCP sub project on its own. So we've got Redfish all over that as the means to manage those systems. and continue pushing on. So it's great to have a common language that that folks can use, and that that they're starting to get some critical mass now in the on the client pieces even, so that folks can start can really take advantage of all the data that's been made available by the vendors. So the big thing for OCP is that because Redfish was intended to be very flexible, so the data model describes a ton of information, but almost all of that information is considered optional by the specification, meaning you don't have to expose all of this stuff. You don't have to have it. It's done that way because the model has to be flexible. So just because servers have memory modules or processors and lots of configuration around those things, well, that doesn't necessarily mean that the other classes of equipment would have DIMM sockets. So I can't require you to model a DIMM socket because, well, if you don't have one, you can't do that. So therefore, modeling DIMM sockets is optional. Well, but gosh, if you're a server management guy, you would certainly like to have those in there. So the way that we do this is through a separate spec called the Redfish Interoperability Profile, or just the profile. And I apologize, that's a horribly overloaded term, but we could not find a better one. So what a profile is it's a document. It's actually is a machine readable. We do it as JSON, but it's done to be human readable as well. And this effectively replaces the spreadsheet of supported functions. So it's a checklist, that you have to have these things and give you some requirements. This is a mandatory, this is an optional component, and so on and so forth, and down into some more detail. There's structure in there for being able to do some optional pieces or some conditional requirements. So if you're this kind of device, then you have to have this, otherwise you don't. Those kind of things. So what that profile document does is it becomes a prescriptive method of giving that, well, effectively that checklist. So what OCP has done in hardware management is we actually have at the moment two profiles. There's a baseline manageability profile and then a server management profile. And so what those are, goes down through the Redfish schema and gives requirements for certain things. So yes, you have to have user management, you have to have eventing, you have to have device discovery, part number, serial number. Those are the kind of things that all have checks on them. And so this profile does two things. Then you can take that document and run through some conformance tests that will go check and validate an implementation to see does it implement everything that is required by the profile. So give you kind of a pass-fail on that. So that's good for both developers and for end users to validate what the vendors are telling them. And then the other thing you can do with that document is, with the JSON document, is you can run it through a human documentation generator that will get you a document that are real specifications you can hand to a developer and say this is what you have to implement. And the tools for doing all of those things are all freely available. They're all on those, on the DMTF GitHub. Any questions? This is old hat for Mohan, at least. Okay, so that background now. The actual data that y'all are interested in. The relevant data from a sustainability standpoint, and I've looked at this in a couple different fashions. Most of this is going to be around measurement of power energy, and then some supporting pieces to make sure that you can do that. So this is kind of I'm diving down to the detail first. This is the pieces that are actually available down at the property level. So there's power reporting. So this can be both instantaneous reading and also an average value. And there's effectively two different readings there. There's an average reading that comes alongside this. The averaging is flexible, so that the implementation can choose over kind of what time scale it's going to average that power reading. And so that's it's allowed to be something that's it could be as short as 5 minutes. It's typically something like 5 minutes or an hour. Just really depends on how dynamic that device wants to needs to be able to capture. But the total is also there. And this is true of all of these measurements. So They're available in various places down in the subsystems, within a larger product. So I can get the total power consumption of a device by looking at its primary chassis, or basically the physical container for all the data, or the physical side of the data model, excuse me. But for servers, there is certainly interest to look at individual CPU power, or individual memory device power, or other interesting subsystems, and so you can report those values as well. And so then the relationships are explained there to show that this is the measurements they're not just listed out on their own. They come in context with the subsystem they're measuring, and I'll show you an example of that in a minute. So similarly available, and again, this is defined in the spec, and this is why we're going to talk about profiles a little more. So similarly defined is energy consumption, and so this is intended to be free running counters, like an electric meter. So consumption since either the unit was first deployed, or since some epoch that the user can specify, so they can effectively you can go reset that. So think of it as the odometer and the trip mileage. So you can report that, but if the implementation allows the user to reset those intervals, then there is the ability to report the lifetime. So a counter that does not get reset. So that's from an actual sustainability. This is really the data that we're talking about. Now the supporting data that can be then used for.
May I interrupt, Jeff?
Sure. I'm sorry.
So for these two, what are we relying on to measure this information? Like, is there? So you don't just like make up a number you think is good, right? Or how do you measure it?
Oh yeah, so these are both intended to be live measurements coming from from hardware. So they are intended to be output of a sensor. This is not a I guess I should have put this on there. So there are things like rated powers, things like the faceplate ratings, the static values.
Yeah,
that's available in the model, but that is not what these are. These are intended to be live measurements.
And what this would typically cover would be like a motherboard and all components on the motherboard, or would it be at a rack level? What is the?
So it can be either of those things. It depends on where this shows up in the data model. I'll show a little example of that. But the point is that no matter where it's placed and what the scope of this property is, it's explained in the model and shown in that context. So you can figure out through the other data that's available, what the scope, and I hate to use that word, what the scope of that reading entails. So generally speaking, a server will report on its chassis, meaning the entire piece of sheet metal that encompasses the product. It'll show the power consumption and the energy for the whole product. So that it's if there's a product that is like a rack manager, and there are several of those implementations, it may sum up all of the power consumed by the entire rack and can report that.
So basically, the RedFish allows you to describe it. It's whether it's you're implementing or not. It's not. It's a lot of things are optional, right? That's where
right.
You want to come back and say like what is required if you want to support sustainability.
And if there's energy, I mean, we know there's energy taken in power conversion in the rack itself. Would that be included in the rack?
Oh yeah. So the definition of both the power and the energy is the is effectively the measured input power. So it's supposed to be, it's effectively, it's supposed to be recorded as like the wall watts. So the amount taken from the wall before any internal losses.
And that's at the rack level as well.
It could, yes, it could be. It certainly can be at the rack level. That depends on what kind of device you're pulling this from, and that's one of the things that I got into with the putting Redfish on the PDUs and UPSs, because that's the guy that's going to have the measurements, for the entire feed.
So has that gotten some uptake?
Yes. So there's at least 3 vendors that have Redfish on some class of their PDUs. I think there's some on some of the UPSs. I need to, that's my next area to go really push at. And so this is going to be my call to action we've got all this stuff defined. We've got working implementations. What I would like to have is I want OCP to be pushing on the profile part of this to say, look, this is the data we need to have to meet the goals of these various work streams. I've got to have the data available, otherwise if I can't measure it, I can't do anything about it, right?
Yeah. And my last line of questioning would be around what's the security and who can access this information? Like, obviously the data center owner, let's say, or the individuals that run the data center would have access, but typically there's a lot of software that gets loaded up, right? And uses 4 cores or 8 cores and out of many cores on the server motherboard, or even more so if you abstract it out to the rack, etc. So is there a way for a tenant that's running software to get access to this data?
There is, and that the permissions model in terms of what data is available and to who, that's built into the spec, so it is secured. It does have a an access control and a user account model in roles and so forth. The primary means that most measurement is going, that most of this access is doing today is through the out-of-band channels, coming out of the server. So it is the data center folks that are getting at it. There is host interface definitions as well. The plumbing to can I make all this available to a tenant running in a container or something? You can. Would you expect to see that today? And that one I think is probably, I'm not sure, because while you can go define the stuff up to go make it available to only particular tenant data, I'm not sure how many folks are going to get to that point yet. But it's all possible. The model supports it. The spec supports it. Getting the OS guys and their infrastructure to allow for that. It's definitely different than what had been done in the previous generations of specs and products. And so it's still some chicken and egg there in terms of, yes, you can do it, and yes, you can do it securely. So that I can restrict the data to to only what that tenant should be able to have access to. But I've got to go, but they still got to do the work, right? So
yeah, that would be nirvana for a lot of people.
yes,
I would just say, I don't know if you're aware, now the 3 large CSPs provide it like in a monthly report, which tends to be not super actionable, right? Because it's rolled up, say you have 750 software developers, it's kind of rolled up for, everybody in any given data center.
Yeah, it's got big scary numbers, so it's
well, right, it's just hard to take action because you don't know who's responsible, who drove it up to 2x this month versus last month. You just, and you plus you get the information in the case of AWS 3 months after the end of the month that they're reporting from.
Oh
Is the
gosh, okay.
number. So yeah, people are doing all kinds of other, how can I put it?
They've moved on.
Not good ways of guessing
Right.
what their power is, you know, very imprecise, very, very low, to be frank, relative to their true power. All right, thanks a lot for letting me.
So yeah, but I think the future is going to be the, you know, we like I said, we've got the data, effectively all these data structures are in there. The question is how much, you know, now you got to go do the actual plumbing to go bring that up. I think, you know, we've had lots of discussions on, you know, gosh, how would you divide up, you know, power? And I think Mohan will probably talk to this too, is that how do you divide up the power? How do you allocate that to a given workload on a system? You know, we've got physical pieces, but then we have effectively these logical components, and they certainly, you know, I can certainly take some good guesses as to, you know, who's using up all those watts. But it's you know, but it's there's going to be some fairness questions, I think, there, and then you know, some debate on you know, where that all goes, right? But and then I think, Susan, your point is, and then how do you make that actionable? You got to make it the data relevant enough to do something with it, right?
Right. I mean, and just to make things even more confusing, you know, typically within a rack, not all the cores have, I'm very server centric, I apologize. Not all the cores have been allocated to do work.
Right.
So who, quote unquote, pays the energy for those waiting cores, et cetera. And then just to make things, you know, to jump out another couple of levels as well, is there's this whole concept of carbon intensity, which is a function of renewables and non-renewables on the grid. And
Right.
these large data center owners will typically have signed power purchase agreements for certain energy at a certain price at certain times of day. What they, you know, they're very complex legal contracts, and so therefore getting from the, you know, the power to what actually was the cost, because even if, you know, it's nighttime and there's much less happening in the data center, the power purchase agreement could very well be asking for constant energy to come to the data center. So therefore, nothing's been saved per se,
Right.
you know,
Mm-hmm.
even though people took the effort to turn off all of their stuff at night or what have you, in the end, it's still the same.
Yeah, hopefully they're not just calculating pi just to keep their minimums up, right? Yeah, but that's but yeah, you're absolutely right, and that's and it's a lot of those kind of questions. And so I mean, I have my folks that are asking, you know, they want to be able to go do those carbon intensity calculations. They want, you know, they want to do all that stuff, and like, well, do I make that data available from the unit? Like, well, the unit's not gonna know, right?
Exactly.
So there's those contracts, you know. So my focus has been on, let me get you the raw data. Let me get you, you know, the gross totals, and then as much granularity as is either feasible or desired from the, you know, from an individual product standpoint. And then let me allow you to find the pathway, you know, where physical locations. So, you know, where this thing is in the world, or is, you know, down to a specific rack row and, you know, in U space, so that you can, you know, you can help to group the things together. Let you trace the pathway of power delivery and distribution through the data center. So I have that capability, and then using that information, you know, you know, some piece of software then can start to apply those things. Like, yes, if all this is coming from a power feed and it's coming from the mainline utility, then that one's under contract and it's all hydropower, so I've got a zero carbon footprint on that, and then but then the other half of the day is running on. So,
actually, yeah, I mean, I've heard people say that, but again, there, people from outside give you a number of the carbon intensity of your grid, but there could be entities on that grid that again have contractually, they paid money up front, or they took some action that enabled the grid to make progress to renewables, and therefore they quote unquote have ownership of the renewables in that energy mix on. So it's just it's even
Oh, yeah.
what you've got here and having software. I mean, now there's at least 2 entities that supply the grid carbon intensity, watt time and electricity maps. But they don't take into account the contractual part of it. So even there, you can be led astray.
Sure. Oh yeah. But again, I'm still at the crawl phase here of.
Actually, this is awesome, and this is the best thing I've ever seen. I'm sorry to be, if it seems like I'm tearing it down. This is.
Oh no, no, you're not tearing it down. You're showing that there's there's a lot of work left to do. So that's the.
I think.
So let me I'll breeze through the rest.
Somebody else is trying to jump in. Who's trying to speak?
Yeah, I think I was trying to say is let's first identify what is currently available, and we probably need to have a discussion on what is need to be added on top of the what is currently available, right?
Yeah, and I guess actually I do even have that on my last slide here was the what other data we need, but that is absolutely the other piece of this whole feedback loop is if there is more data that we can go place it's either stuff that can be discovered or things that the user can go set so that other pieces of software can discover that information. That's all good. And we will absolutely do that. That's how this spec has grown over the years is through feedback from from end users saying, hey, I need this piece of data. So we took a different approach with these data models and tried not to just throw everything out that the hardware made available. Of like, let's make sure that this has got a purpose and that somebody needs and can do something with this data. Otherwise, we're just creating a lot of work for folks, and that's one of the things that hampers adoption of a lot of the systems management things is boy, there's an awful lot of stuff here that has to be done. It's like, well, I need to make I want to make sure that it's being done for for real purpose, not for speculation.
Yeah.
So here, let me run through the rest of this. So as Susan's explained, like being able to find where this thing is, where its power is coming from. But we're not putting in things like those carbon intensity numbers because again, the device itself isn't going to be able to get that without a lot of external data, and then it could be misleading. So there's questions there as to should we do more there, and I'm not sure. It seems like that that if I can just describe the kind of the actual metrics coming out of the energy readings. And then give you the where in the world and how am I connected to the grid or grids, then something else should be doing those calculations above. And then lastly, because there's like went through the things like what other stuff outside of power and energy, what other sustainability data is available in the model, what would be relevant. There have been some discussions that especially on the liquid cooling side that folks would like to be able to show the amount of heat reuse that's going on as a way to sort of kind of counterbalance some of that usage. So there's some talk about that. That's not in the model yet, but it's certainly something that we can add if we can get some definitions for that. And then a lot of the other pieces is like trying to do system inventory. So if you're trying to do the calculations on or an inventory of embodied carbon or and this could be done at any kind of time point in the life cycle of the product. Could be during development, could be at acquisition time, and so forth. To go find out all the different parts that were involved in that system. There's a lot of system identification, and I've got highlighted here. It's like make, model, and SKU and part numbers and things like that. So that can be useful for gathering that data up. So But again, that's kind of all crawl phase, and what data else needs to be added. Please let me know.
So Jeff, regarding the fan power, like VR and other powers, do
Yes.
we have that already available, or?
Yeah. So the fan or the thermal subsystem that you can get, that there is a power and energy available there, so that you could report out the total amount of power being used for the entire fan or the thermal control subsystem. So I made sure that that's available in the model. Now, are people reporting that yet? I don't think so. There may be. I mean, it's probably not broadly adopted there, but I think that again, that's an area that OCP can help in to say, yeah, I need to have those things. So I need to see your total fan power, because I'm going to subtract that out from an efficiency, for these metrics as we're talking here.
Right.
But the important part from this side is the way that gets reported. It's all the same. So if I get 5 different power readings, they're pulled out from different URIs, but the format and the property names and how that data is presented is the same. So you just get a bunch of different measurements, but they're all in the same format. So from a data analysis, it's very easy to go write a piece of software that's going to do something with that data, because it's effectively normalized across the data model. And I'm going to try to finish up because I want to make sure Mohan's good. So this is all kind of the behind the scenes. I'll wherever the appropriate places, I'll go upload this so folks can kind of read this. But so the model, the data model that backs all this stuff up, there's a common definition in Redfish for what is a sensor, and again, overloaded terms. But every sensor has a reading, and so that's the actual value. So if that's 312 watts or 67 kilowatt hours, all of that is a reading for a specific type of sensor. The sensors themselves, so if there's a bunch of different power and energy readings, those that might be there might be a dozen sensors, or there might be actually 30 or 40 if it's a PDU, because you got voltage and current and frequency and so forth. All of that stuff is all in sensor resources. They're all collected up in a collection, which is just a Redfish term for one or more of something, one or more instances of something. So you're able to go discover all that data, go pull that, go do operations in bulk on all the sensors, filter them out by I just want to see the power ones, things like that. And that's for doing that's good for doing bulk retrievals and other kinds of metric reports and so forth. For users trying to actually figure out what this data all means, they don't have to dive through all that gory detail. They can just get access to the reading of a sensor as it's placed as a small copy, or what we call an excerpt of a schema that gets placed out in context. So under a processor, there is an environment metrics that shows the temperature and the power and the energy of a processor, but it doesn't have all the gory details of all the sensor stuff. So it's basically trying to get you to get all the data that you really wanted to do. And if you want to see more data, you can go dive into it, but you don't have to go filter through it all if it's not, if it wasn't relevant. So picture worth 1,000 words. So here's some more text. So this is just an example of what a sensor resource looks like. So this is what you would actually get if you pulled it up in any piece of software or Postman or a web browser and went to a particular sensor. This one's a temperature one. But there is our reading. So in this one, this is in degrees Celsius. That's all defined by spec. And you can see there's the ability to go set a bunch of thresholds. There's the averaging information, when the stuff was read, the peaks and the valleys of those the history of that sensor. All that stuff's available. That's a lot of data. Most folks don't need it. And so here's a better example for this group. And this is the environment metrics, which is the common resource that's scattered throughout the model that shows where all these power and energy readings show up. And like I said, under us, this may be and here's an example here. This is actually under a processor. So under processor number 1, here's the power and energy for those processors. And if you as a customer want to go dive deep into the gory details of the sensors and all the data behind that, then here's the breadcrumb tracks that provide you the way to go find the sensor that provided that data. But wherever you're on the model, there's that power watts and energy kilowatt hour is shown consistently. And this is just a list of the different schemas where these measurements show up. So if you go look at our schema guide, these are the ones to go look at. And so I'll just kind of showing those there, and then the how they get used. Suffice to say, there's lots of places that people can instrument data, and what we want to do is get folks to do that. And then lastly, I won't go into details here, but the one of the ways that that software can be written to take advantage of this stuff is to use the telemetry service that's a function of the Redfish data or the implementation, so that you can define out reports with times and guardrails and all this kind of stuff. But can go build up and get a report of like things like power, energy, and temperature, and have that sent to you. It's either as a stream or as effectively as a report format. So those things are also part of the model. All right, and I've got a lot longer than my 15 minutes. So so this is the call to action. As I said, Mohan kind of touched on it, but I want this work stream to specify, what data is important. What do we want all of these products to be showing, and then, as I said, since I'm co-chair of the hardware management group, I want to take those things back and go make a Redfish profile. I think it would be good for us to actually have, a sustainability data profile to say that, look, I want you to, regardless of what kind of product you are. If you're going to get an OCP, check mark or however you want to state that, you need to expose enough data that the sustainability software and all these various products can harvest this data and then be able to go do some good with. So to me that seems like, look, I want to have at least power and energy at the total device. The overall power consumption of your gear. I'd like enough information about the product to be able to figure out what it is I'm looking at. That's probably the easiest, but it still has to be stated. And then give that all as a simple, a small and hopefully easy checklist, but something we can get some consistency for. And then obviously they'll go drive that back to all the other OCP groups to say, look, this is what, if we're going to be serious about measuring and being able to start reporting a lot of these metrics, we've got to have that. We've got to have these baselines and have enough data there for us to operate on. And if you want to learn more, there's plenty of links to go do that. The main one is redfish.dmt.org. That'll get you that'll get you links to everything else.
This is great. Thank you.
I'm sorry, Deb. I keep calling you Susan. I think it's because I see sustainability on the.
Oh, no worries.
Yeah. Thank you, Jeff. It's a really good summary of all the things going on. So it's basically there's two parts to this, right? One is if you want to add something that is not three things. First, I think this group need to identify what are the things needed.
Yes.
And the second thing is on do we need anything extended from existing Redfish or not? If it is not, then OCP profile can prescribe what is want to be needed in order to support this additional sustainability activities in the OCP profile itself, or maybe needed to extend Redfish to comprehend some additional items there, right?
Yep.
Okay.
Yeah,
So let us, I think,
yeah, this is perfect, Jeff, right? So as you know, I'm coming to your work group this Wednesday to talk about the liquid cooling
Yes.
proposal. Well, I would love to, after we discuss here, I'd love to bring in the sustainability profile also. This ties in very well with some of the stuff that you showed with the L1, L2, L3 issues that I pointed out last
Yeah,
week.
and kind of what I was coming to, Mohan, was that, you know, I mean, I certainly on a server management standpoint, I mean, we would certainly have in a profile today, you know, we would say that, you know, server would have to have, you know, power and energy reporting, but I'm going to have that, you know, and that's just going to be kind of that's the care and feeding of a server these days. So, but, you know, and I've got lots of other requirements, but I started thinking about it, it's like, you know, it would be good just to have, I think, just a sustainability data profile
Right.
that doesn't worry about things like temperature or link speed and, you know, all the rest of the things that
Right.
are
Right.
really important data. But and I didn't really mention it, but profiles can be built on top of each other. So this is not like an either or. You know, we can just say, hey, as a baseline of a managed product from OCP, you know, you should have the sustainability data exposed. Period. You know, whether you're a server or a network switch or whatever. You know, that I think that would be a good idea.
Right. Right. So we'll yeah, I've been working on it, but I'll review it with you guys at some point, and then I'll bring it in.
All right, let me turn it over to you. So let me stop sharing this so you can.
And let me finish up.
I will make Mohan as a presenter.
I think somebody's trying to talk to me.
Hey, hi Jeff.
Of
If I could just confirm one very quick question, also because I joined extremely late, so sorry about that. So previously we were talking about you know, metrics that were more at data center level, but what you were showing is completely focused on the device level.
Yes, and it's and then what constitutes a device is flexible. So, you know, if you were the point is that the data is normalized and the way that you access it is the same. So if I can present an entire rack level, you know, view, or I can drill into a specific server or into a single processor, and the way the data is provided is the same. So
oh, I see.
it's not a guarantee that you can do that because somebody has to actually go implement those things. But from a software perspective, you know, if once it's been done, I access it the same way.
Okay, okay, yeah, I see what you mean. Yeah.
Okay.
Thank you.
Thank you.
All right.
Let's
So
to more.
how much time do we have? I'll try to cover it quickly. Just to round up the discussion that we were having last week. There are a couple of metrics that we couldn't get to, which I wanted to close out on. So there's another one called WE, water usage effectiveness, and it's a ratio of the data center water usage by the total IT energy. It's measured in liters per kilowatt hour. According to the US government, the average is 1.8 liters per kilowatt hour for data centers across the US that they measured in general. So that's the metric. So the problem with the metrics and why this forum needs to do something about it is that the period over which the WE is measured. So for example, the US government measurement recommendation is it's an annual measurement, right? So we need to maybe tighten that. So when they measure WE, they just take the data center water usage and compute WE on the basis of that. They don't really comprehend. So essentially, what I'm showing in the slide is on-site water usage. There is a lot of off-site water usage in terms of getting that electricity. Think about like a coal burning power plant, right? It's a power plant. In order to get there, you spent a lot of steam, and that steam, you spent a lot of water generating that steam. Those are not accounted for. And if you're a sustainability minded person, then you want a comprehensive view of that kilowatt hour, not just your little view of the world in general. So there is a scope to expand this metric to comprehend that. And these days, there is also folks that run groundwater to their data center. And the way this metric is currently constructed, it gives them no accounting for the for the allowances for the brown water. And there are also folks that run closed loop, right? Either water or a water glycol mix, either within their racks or from their rack or tank or whatever it is to their dry cooler, for example. And there's not good clarity on that either, and we need to tighten the language there on what we want to do. So those are all the limitations that we need to fix. So first step, in terms of fixing the WE, a more comprehensive WE would be on-site plus off-site water usage, and then that ratio for the total energy gives you the true number. Again, according to our Department of Energy, uh, the number for on-site water usage on average, and compared to the off-site, there is like a huge ratio. There's like a 3x. You spend 3x more getting that power compared to whatever water you're using in the data center. So if you just take the on-site view, you're getting a pretty myopic view of what your total impact of the environment is. And then for brown water, essentially, I mean, this is my proposal. We don't have to go with it, but just for the sake of discussion, we need to subtract out the brown water usage because you need to give folks credit for the good environmental work that they're doing in here, right? So, and then make this an annual metric, meaning measured over a 12-month period, and then this excludes anything that's water or water and some other chemical mixture that's running in a loop that never gets out, right? Because you don't really, it's only things that you end up using that should be included. One-time use that just stays inside the data center forever should not be part of this metric. So there's a few things that we need to go fix, and that should help us get to a more comprehensive view. And when we define the profiles, we need to define it this way. Okay, now I don't have time. So there are no questions. I'll finish up with global warming potential. So global warming potential is essentially the ratio of energy that a ton of gas absorbs over a given period to the same for the same period what carbon dioxide would have done. So by that definition, if global warming potential of carbon dioxide is 1, right? So because the numerator and denominator are the same. So the problem, I mean, where this forum needs to get into a little bit is that, so you can report them over any number of years, okay? So typically, US government is all are 100-year based when US government refers to GWP. But there are folks that do 50 and 20 and whatever other number. So without knowing the number, you really don't know what it is that you're dealing with. And why do people do different numbers? Because so these gases have a lifetime of their own. If you have a shorter lifetime, uh, as a data center, you're better off reporting the 100-year GWP because the number tends to be very low. If the gases have a longer lifetime, you're better off reporting 20-year GWP because your number tends to be lower than if you try to report 50 or 100. So there is absolutely opportunity to game the system here in this thing. So as a body, we need to essentially at least come up with some tightening of the terminology where we know that it's the OCP GWP 100 or OCP GWP 20. So when I come in and say my GW is 23 and you say your GW is 50, am I better than yours? Today we can't tell because I don't know what your basis is, right? So that, I mean, it's a simple issue, but we don't need to go fix it. So otherwise, we talk in abstracts without any depth to any of these topics in general. And I'm not going to get into another issue here is that some folks find GWP very limiting, so they came out with something called GTP. And that's probably a discussion on its own if you want to have a discussion on whether is GWP even the right thing or should we do something more. Because so I'll say this for the sake of completeness, but we don't have to get into it. The reason that people don't like it as GWP is that they say, well, so what if it stays in the atmosphere? But if it causes no global warming at the end of the day, who cares? And global warming, you have to decide by the eventual rise in the environmental temperature. If it did nothing to it, then my gas had no impact. Whatever my emissions had no impact on the environment. So that's the basis for the new metric that people are trying to propose. Uh, that's a philosophical debate that we can have on how we measure that. But for what it's worth, I would rather at least work on fixing these metrics that we have and tightening them and having a profile around them from this work group.
Mohan, about GWP, I was just wondering. So I understand what you're saying about GWP 20 versus GWP 100. It will be different for different. Well, lifetime is different for different gases.
Yep.
I was wondering if the GWP for different gases are based on different years, how are we thinking about having the total GWP from one particular, activity or process? Because that process probably, releases these two different gases, suppose. One of them has a lifetime of 100 years and the other has a lifetime of 20 years. So if I want to, tell what is the total GWP of that process, it would not really be correct to add the two.
Right.
Or that's what I was.
Yeah, exactly. You cannot add them. You have to separately report the GWP of each one of them, and you have to work on minimizing each one. Yeah, you cannot have a cumulative one for the process. If you want to have one for the process, GTP is a better metric. I didn't put anything in this presentation for GTP because GTP is not a quick discussion. It's a much longer discussion on the math alone. Because GTP essentially says, show me how much the temperature changed as a result of my activity. And then you have to figure out what is the contribution of your activity into it and so on. So it's a little bit more involved. We can talk about GTP and which one is the better metric, or maybe there is a different metric that we need to think about. But my goal was not so much to figure out the gaps in the metrics per se. In a fundamental way, I was just trying to figure out, what can we do to fix gaming of the system, so there could be a OCP profile that says, here is what the metric is measuring, and I can compare when you give me two numbers, right? Which we cannot do. I mean, that's a consistent theme in everything I've shown, right? PUE, EW, everything. I can't really compare because they deliberately make it harder for you to compare today. And we as a sustainability body, we need to go fix that.
So Mohan, this is applicable only for liquid cooled
No.
or immersion cooled system, or is it for even
No, anything that emits, that has an emission in general, right?
So GHG protocol is specific about which gases you need to report, and I'm pretty sure it's the 100 methodology.
For America, for the United States, the government recommends it.
Well, I'm for corporations that report on GHG protocol. That's an international standard. So, and that standard, they do not cover all GHGs, and I do not know why that the decision was made. They have added over time one or two, but they're very specific on how you measure it. And it seems that, like I said, that's a global corporate standard that everybody that files Task Force for Climate Disclosures or CDP, or now the SEC is going to use that same thing. So it's sort of, for people that are disclosing and they're going to be to some degree legally bound to be following, that seems to be where there's been a coalescing of how to do it. I completely agree that, a random vendor out trying to sell their stuff, for sure they're trying to game the system. We've certainly seen that. But at a corporate level, there is supposed to be accountability, and there is a international standard, the greenhouse gas protocol.
Yeah.
Yeah.
I'm trying not to mention the names of some countries that don't do that. But yeah, I think if you have something, then we can say this is what you did. All I'm proposing is we tighten the language on that one. But
Good.
Shruti is bringing up a much bigger issue, which we need to talk about. But there are other things. So I wasn't thinking this is the primary order because most of us here are our background is in IT or technology, I should say. So I don't know if this is where you would take your first focus. But for completeness, I just wanted to say that.
Okay.
Go ahead, Sammy. You were saying something.
Yeah. And we are also top of the hour, and thank you, Mo and Jeff. Do you want to have any other topics we want to bring in, or we want to start discussing what we want to get the metrics defined in the next meeting?
So would OCP be able to fund us to look at the EU specs for a lot of these different metrics? Because again, there's the weight of law behind those definitions. So at a minimum, we should know what they are.
Mohan, you're much
Sorry,
closer to the.
say it again, Deb. I
So
missed
a
the last.
lot of the metrics that we are interested in,
Mhm.
the same three-letter acronyms, right, are being used for the EU regulatory for data centers, for what
Yep.
they have to report.
Right.
So can OCP invest in purchasing those EU specs so at least we know what that center of gravity is? If we decide to move away from that, we can have that discussion, but at least we'll know a large number of entities will be reporting based on those metrics, those definitions.
I don't think we have to even invest. One organization to another, they usually don't charge for these things.
They charge, I can't remember, but it's hundreds of dollars for PUE, hundreds of dollars for WUE, etc.
So send me a pointer. I will contact them officially and get it from them. Usually, if you use your official email address and contact them, it's a different story. One organization to another, they probably won't do that.
That would be great. Excellent.
Yeah, send me a pointer. So yes, I mean, to answer your question, we do want to go to the next step, which is to define that profile. As I said, for liquid cooling, already defined that profile, and we're going to propose it to Jeff's work group this week.
Okay.
But we need the sustainability profile defined, and then we should take it to Jeff's hardware management work group after that.
Okay. So then let's probably start the discussion on what are the things we want to include in the metrics starting next week.
And Deb, if you could send those pointers out to those specs to all of us actually, because I've certainly got sustainability folks within HPE that and they're all over the EU requirements as well. So I'll do some digging to see if we have those specs.
That would be great. My understanding is that whatever entity bought it is sold either per person or for that entity only. So
right.
If you have them, you may need to summarize them. I believe I sent it last week, but I will send again.
Okay. I see it last week. Was it in that presentation
Yes. Yes. If you
Okay.
go, there's a slide in that presentation that lists all the metrics and then the number or name of the specification.
Okay, I've got that. So
Yeah, if you could ask around, because what I was told is that even if it belongs to a certain corporation, that somebody can read it and summarize it for others.
correct. Yeah, there's
That would be good. All right,
exactly.
so we'll
Yeah.
try those two
Can't follow the
different.
specs, but we can talk about the content.
Yeah, exactly.
Thank you,
All
Tim.
right. Bye.
Thank you, Jeff and Mon. We'll see you next week. I think if you are able to get any progress on the spec, let's have the discussion also next week.
That's good.
Otherwise, we'll start looking into the new things that we want to define.
All right. Sounds good.
Great. All right.
Thanks.
Thanks.
Bye, Jeff.
This conference will now be recorded.